Autumn 1941. A German inspection area outside Tobruk, Libya. The captured M3 half-track sat in the desert sand, its American white star crudely painted over with a hasty black cross. Oberst Friedrich Weber circled the vehicle with skeptical eyes, his engineering team already poking and prodding at what appeared to be nothing more than a thin-skinned truck with tank treads bolted to its rear. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. A truck with tracks, Weber scoffed, running his gloved hand along the vehicle's modest armor plating. 6 millimeters at best. One well-aimed burst from an MG-34 would turn this into a rolling coffin. The inspection team nodded in agreement, scribbling dismissive notes about this newest American contraption captured during Operation Crusader. The half-track still bore its original designation stenciled on the rear compartment, USA 302644, manufactured by the White Motor Company. German intelligence had received fragmentary reports about American half-track production, but seeing the physical vehicle confirmed what they had suspected. American industry was focusing on quantity over quality. The Americans think this toy will change the battlefield? A junior officer laughed. Our Hanomag Sti, KFC 251, is superior in every way. German engineering pride was on full display as they continued their cursory inspection. To them, the M3 was nothing more than an improvised stopgap, certainly not a vehicle that would ever cause them concern. It lacked the refinement of German design, the precision of German manufacturing, and the combat-proven capabilities of German half-tracks already deployed across Europe and North Africa. Yet, as Weber motioned for the team to start up the engine, the first hint of surprise registered on their faces. The white 160AX six-cylinder engine fired immediately, despite the harsh desert conditions it had endured. No coaxing was needed, no adjustment of the carburetor. It simply ran as if it had just left the factory floor. The German team exchanged glances but remained unimpressed. Any vehicle could start once. The real test would be in sustained operations. The real revelation would come in the weeks that followed. Rather than ship the captured half-track back to Germany for evaluation, practical battlefield necessities dictated its immediate use. The Afrika Korps was desperate for any mobile transport that could navigate the harsh desert terrain, and despite their derision, Weber reluctantly assigned the M3 to a reconnaissance unit with orders to drive it until it failed, which they assumed would be soon. But it didn't fail. Day after day, the captured M3 churned through sand, rock, and hard-scrabble desert tracks, while German Opel Blitz trucks, and even their own half-tracks, frequently bogged down in the softer sands. The M3's combination of front-wheel drive and rear tracks consistently pushed through. German mechanics, accustomed to performing field repairs on their vehicles after even modest journeys, watched with growing dismay as the American half-track required virtually no maintenance beyond basic fluid checks. The reconnaissance unit began filing unusual reports. Unlike the German SD, KFZ, half-tracks with their sophisticated but finicky track systems, the M3's simpler track design appeared almost immune to the fine desert sand that routinely jammed German running gear. The rubber and metal band tracks shed sand instead of capturing it. More concerning, they reported that the M3's crew compartment could comfortably accommodate 12 fully equipped infantrymen, significantly more than their own vehicles. By December 1941, what had started as dismissive curiosity had transformed into reluctant admiration. The captured M3 had travelled over 2,000 kilometres across the North African battlefront without a single major mechanical failure. No transmission issues, no cooling problems, no track failures. The simple, commercial-grade automotive components that German engineers had initially mocked for their lack of sophistication were proving to be the vehicle's greatest strength. February 1942 brought the first comprehensive German assessment report on the M3, marked for command staff only, and signed personally by Field Marshal Erwin Rommel. It stated plainly what German engineering pride had been reluctant to admit. The American M3 half-track represents a logistics capability that our current vehicles cannot match. Its mechanical reliability under desert conditions exceeds our SD, KFZ, series by significant margins. The implications for sustained combat operations are concerning. Rommel understood immediately what his engineers had initially missed in mobile warfare across vast desert expanses. Mechanical reliability was more valuable than armor thickness or weapon specifications. A vehicle that reached the battlefield consistently was infinitely more useful than a superior one that broke down en route. He ordered the capture of additional M3s whenever possible, recognizing their value even as his engineering staff remained dismissive. Spring 1942, German testing facility at Kummersdorf, Brandenburg. More captured half-tracks had finally made their way back to Germany for proper evaluation. Engineers who had never experienced desert conditions approached the M3s with the same initial skepticism as their counterparts in Africa. But systematic testing soon revealed truths that would challenge fundamental German assumptions about military vehicle design. The professional testing at Kummersdorf uncovered design elements that had eluded the field evaluations. German engineers were genuinely surprised by what they found beneath the M3's modest exterior. The drivetrain featured a transfer case that distributed power efficiently between the front wheels and rear tracks, a system different from but conceptually superior to German designs. The suspension system used standard commercial truck components, but arranged in configurations that maximized off-road capability without sacrificing reliability. Most revealing was the White Motor Company's approach to the transmission. Where German half-tracks employed sophisticated but maintenance-intensive gearboxes that required skilled drivers and frequent adjustment, the M3 used a commercial truck transmission that any driver with basic training could operate effectively. German vehicles prioritized theoretical performance maximums that impressed in specifications but demanded expert maintenance. The American design prioritized consistent performance under field conditions with minimal maintenance requirements. The cooling system revealed another fundamental difference in design philosophy. German cooling systems were precision-engineered for optimal efficiency, but struggled under extreme conditions and required meticulous maintenance. The M3's cooling system was deliberately overbuilt, with greater capacity than necessary for normal operations. This seemingly wasteful approach meant the system could handle extreme desert heat without failing, even with less than perfect maintenance. Preparing and narrating this story took us a lot of time. So if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. These revelations triggered heated debates among German military engineers throughout the summer of 1942. One faction insisted that German design superiority would ultimately prove decisive, while another group, primarily those with actual battlefield experience, argued that the Americans had discovered something more fundamental about modern mechanized warfare: the critical importance of vehicle availability rates. By mid-1942, American industry was ramping up M3 production at a pace German observers found almost impossible to believe. The White Motor Company, Autocar Company, and Diamond T were producing half-tracks not by the hundreds but by the thousands. Intelligence reports indicated that the Americans planned to manufacture over 40,000 of these vehicles, a production figure that stunned German planners who struggled to produce even a tenth of that number of their own. Half-tracks. Each M3 could transport a full infantry squad with all their equipment, effectively mobilizing entire armies at speeds that traditional military planning had never contemplated. German strategists, who had pioneered blitzkrieg tactics, now faced the prospect of entire American armies with similar mobility but vastly greater mechanical reliability and logistical sustainability. In a particularly revealing exchange documented in captured German records, a senior Wehrmacht transport officer wrote to Berlin in August 1942, "The American approach to motorization represents a different philosophy than our own. Where we seek technological superiority through precision engineering, they seek operational superiority through simplified designs and mass production. One M3 half-track that remains operational for 3 months without major maintenance is worth more than 3 of our vehicles that require workshop attention every 2 weeks." This assessment proved prophetic, as Allied landings in North Africa in November 1942 brought waves of M3s to the battlefield. German commanders reported with increasing alarm that American forces were achieving mobility rates they could not match. While German maintenance units struggled to keep their half-tracks operational, American maintenance requirements were minimal, allowing them to sustain offensive operations that German forces could not counter too effectively. The M3's versatility further demonstrated American industrial thinking. The basic chassis was rapidly adapted into a bewildering array of variants: anti-aircraft platforms mounting quad 50 caliber machine guns, mortar carriers, ambulances, command vehicles, and anti-tank gun platforms. Each variant maintained the same mechanical reliability while serving specialized battlefield functions. By 1943, German intelligence had identified more than 20 distinct variants of the M3 in active service, all sharing the same basic mechanical components. As the tide of war turned against Germany, captured documents reveal an increasing German appreciation for what the M3 represented. A 1943 assessment from the German Army Weapons Office stated, "American vehicle design emphasizes 3 principles we have not adequately prioritized: mechanical reliability under field conditions, ease of maintenance by troops with minimal technical training, and component standardization to simplify logistics and repairs. These principles, more than any technical specification, determine battlefield effectiveness." The Battle of Sicily, in July 1943, provided the final vindication of the American approach. As Allied forces pushed inland from their beachheads, their M3 half-tracks maintained nearly 90% operational readiness despite difficult terrain and combat conditions. German mechanized units, by contrast, reported readiness rates below 50%, with some units unable to field more than a third of their authorized vehicles due to maintenance issues. The mobility gap had become a decisive factor in combat operations. The mass production of M3s continued at an almost incomprehensible scale to German observers. By early 1944, American factories had produced over 35,000 half-tracks, more than all German armored vehicle production combined. This production miracle was achieved not through superior manufacturing technology but through design philosophy. The use of standard commercial components, simplified production techniques, and an emphasis on field reliability over theoretical performance specifications. As Allied forces prepared for the invasion of France, German intelligence assessments grew increasingly alarmed about the implications of American motorization. A February 1944 Abwehr report warned, "The American ability to maintain mechanized mobility at the scale they have achieved will allow them to conduct offensive operations at a tempo we cannot match. Their vehicles are designed not for optimal performance, but for consistent performance under combat conditions, a distinction we have failed to fully appreciate until now." The Normandy campaign confirmed these fears. As Allied forces broke out from their beachheads, vast columns of M3 half-tracks carried infantry, supplies, and supporting weapons at speeds the retreating German forces could not counter. While German mechanized units struggled with vehicle breakdowns and fuel shortages, American forces maintained relentless offensive pressure across the entire front. What German engineers had initially dismissed as an unsophisticated stopgap had proven to be a masterstroke of practical design. By September 1944, captured German assessment documents no longer contained any trace of their earlier dismissive attitude. Instead, they reflected a grudging but profound respect for American industrial philosophy and its battlefield implications. A final comprehensive German analysis, dated October 1944 and recovered from captured Wehrmacht archives after the war, concluded, "The American M3 half-track program represents not merely a vehicle, but an industrial approach to warfare that we failed to anticipate. Their emphasis on reliability, maintainability, and mass production has proven more decisive than our pursuit of technical sophistication. A weapon that works, consistently, even if theoretically inferior in capabilities, will always defeat a superior weapon that functions intermittently." By war's end, the United States had produced approximately 41,000 M3 half-tracks and variants. They had served on every front, transporting millions of troops and thousands of tons of supplies across the most challenging terrains of the war. German forces, who had initially laughed at their simple design and modest specifications, had learned through bitter experience that theoretical superiority on paper meant nothing compared to actual performance in the field. The story of the M3 half-track is not one of technical innovation or battlefield heroics, though it certainly enabled both. It is instead a story of American industrial philosophy applied to the problems of modern warfare. The principles that governed its design, reliability, simplicity, standardization, and mass production, would continue to influence American military procurement long after the war ended. In the decades that followed World War II, German automotive engineers would incorporate many of these lessons into their own designs. The emphasis on reliability and maintainability that characterized post-war German vehicles owed much to the hard lessons learned from their encounters with the seemingly humble but ultimately triumphant American M3 half-track. For military historians and planners, the M3's legacy offers a timeless reminder that in warfare, consistent good performance always trumps intermittent excellence. The vehicle that reaches the battlefield and functions as intended will always prove more valuable than the theoretically superior design that fails to do so. This principle, demonstrated so conclusively by the M3 half-track, remains as relevant in the 21st century as it was in the battlefields of World War II. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. June 1944. The fields of Normandy, France. American troops poured inland from the beaches, riding waves of olive-drab M3 half-tracks that churned through the hedgerows and narrow lanes of the French countryside. Private First Class Michael Donovan of the 1st Infantry Division clung to the side rail of his platoon's half-track as it navigated around a destroyed German panzer. The irony wasn't lost on him, a thin-skinned American transport outmaneuvering what had once been the most feared tank in Europe. "Keep moving," shouted Lieutenant Parker from the front cabin. "We've got a 5-mile push before nightfall." The column of half-tracks stretched back toward the coast, each carrying a full squad of infantry, their equipment, and the collected determination of an army on the offensive. 3 years earlier, German officers had laughed at the M3's modest armour and straightforward design. Now, those same German forces were in full retreat, unable to match the mobility and sustained offensive pressure that these inferior vehicles enabled. As the half-tracks pushed deeper into France, they passed abandoned German vehicles, sophisticated half-tracks and tanks sitting forlorn by roadsides, their complex drivetrains and transmissions having failed at the worst possible moment. German infantry, once the spearhead of blitzkrieg, now marched on foot while American forces rolled past in their reliable, mass-produced transports. The mobility gap that had seemed theoretical in 1942 had become a devastating reality on the ground. "They say we've got more of these half-tracks than the Germans have bullets to shoot at them," joked Corporal Wilson, seated across from Donovan. The comment drew tired laughs from the squad, but contained a profound truth. The sheer industrial scale of American production had created a numerical advantage that no amount of German engineering sophistication could overcome. Meanwhile, at a German repair depot 20 miles to the east, Hauptmann Gerhard Müller surveyed the broken-down vehicles crowding his maintenance yard. His skilled mechanics worked frantically on sophisticated but fragile transmissions, complex electrical systems, and overtaxed engines. The contrast couldn't have been more stark. While American forces pushed forward in their reliable vehicles, German units waited days or even weeks for parts that would never arrive. Another SD, KFZ, 251 with transmission failure, Müller noted grimly as a tow truck dragged in yet another disabled half-track. Third one this week from the same battalion. His chief mechanic, a civilian automotive engineer before the war, spat on the ground in frustration. They designed this transmission for a 9-ton vehicle, then loaded it to 12 tons and expected it to perform. Meanwhile, the Americans build their half-tracks like tractors, simple, robust, with components twice as strong as they need to be. This fundamental difference in design philosophy had become increasingly apparent as the war progressed. German vehicles had been engineered with theoretical performance as the priority, speed, firepower, and technical specifications that looked impressive on paper but required perfect conditions and meticulous maintenance to achieve. American vehicles, by contrast, were designed for the harsh realities of actual combat conditions: dust, mud, inexperienced drivers, and limited maintenance opportunities. July 1944 brought a pivotal moment in the Allied breakout from Normandy. Operation Cobra unleashed thousands of half-tracks in a coordinated offensive that German forces simply couldn't contain. The operational readiness of American mechanized units consistently exceeded 85%, while German readiness rates had fallen below 40% in many sectors. This disparity transformed what might have been a battle of equals into a one-sided advance. A captured German officer, interrogated behind American lines, expressed the growing German frustration. "We were told your equipment was inferior, mass-produced by factory workers rather than crafted by skilled engineers. What we weren't told was that your inferior vehicles would still be running when our superior ones were awaiting spare parts that never came." This sentiment echoed through the ranks of the retreating Wehrmacht. German infantry, trained to fight alongside their own half-tracks and armoured vehicles, found themselves increasingly abandoned by their mechanical support. The psychological impact was devastating. Not only were they outgunned and outnumbered, but they were being outmaneuvered by an enemy whose equipment simply refused to break down. The M3's versatility further magnified its impact. By mid-1944, specialized variants were appearing throughout the European theater. The M16 multiple-gun motor carriage, with its quad 50-caliber machine guns, provided devastating anti-aircraft fire. The M21 mortar carrier delivered mobile fire support. The M3A1 ambulance evacuated wounded soldiers with unprecedented speed. The basic chassis adapted to virtually every battlefield role, creating a unified logistics system where parts and maintenance procedures remained consistent across all variants. August 1944 brought another dimension to the M3's impact as Allied forces closed on Paris. French resistance fighters, emerging from hiding to join the liberation, marveled at the sheer volume of mechanized transport available to American troops. One French officer, who had fought in 1940 only to see his unit overwhelmed by German mobility, noted in his diary, "The Americans move their entire army as we once moved only our elite units. Every common soldier rides in a half-track or truck, carrying with him ammunition and supplies that we could only dream of in 1940. The America that Germany dismissed as unprepared has mechanized warfare beyond anything we imagined possible." This transformation had implications far beyond the battlefield. Behind each M3 half-track stretched a logistics chain that represented American industrial might at its most formidable. The vehicles weren't just transport, they were the visible manifestation of factories working around the clock, of production systems refined to unprecedented efficiency, of an industrial base so vast that it could equip not only American forces but Allied armies across the globe. German intelligence officers, monitoring this industrial output from afar, grew increasingly alarmed at what it represented. A September 1944 assessment recovered after the war contained this sobering conclusion. American industry now produces more M3 half-tracks in a single month than our factories can produce of all armored vehicles combined in the same period. This disparity cannot be overcome through tactical innovation or fighting spirit alone. It represents a fundamental strategic advantage that will prove decisive. This assessment proved prescient as Allied forces pushed toward the German border. The mechanized mobility gap widened rather than narrowed as the war progressed. German vehicles, already struggling with reliability issues, faced additional challenges as fuel shortages and spare parts scarcity further reduced their effectiveness. American half-tracks, by contrast, operated with a logistical abundance that German commanders could scarcely comprehend. Fuel, spare parts, and maintenance support seemed limitless. October 1944 brought the first M3 half-tracks to the German border itself, their tracks now churning through the same soil that German engineers had once considered impervious to American military reach. The psychological impact on German defenders was profound. The vehicles they had once mocked were now breaching their homeland, carrying with them the imminent reality of defeat. A German Home Army Volkssturm officer, writing in his journal after encountering American mechanized units for the first time, captured this psychological turning point. "We were told for years that American equipment was inferior, mass-produced by unskilled workers rather than crafted by German engineering precision. Yet their half-tracks roll forward without stopping while our superior vehicles sit idle for want of parts or fuel. Their quantity has a quality all its own." This recognition, that quantity could become a quality in itself, represented a fundamental shift in military thinking. The traditional German emphasis on individual vehicle superiority had been overwhelmed by the American approach of standardized mass production. A technically superior vehicle that couldn't reach the battlefield due to mechanical failure was worthless. A technically adequate vehicle that arrived reliably and in overwhelming numbers was decisive. As winter 1944 closed in, the M3's advantages became even more pronounced. Its robust heating system kept crews functioning in freezing conditions. Its simplified maintenance could be performed with basic tools, even in adverse weather. Its standardized parts meant that disabled vehicles could quickly donate components to keep others running. German vehicles, with their more complex systems, suffered disproportionately as temperatures dropped and maintenance became more difficult. By December 1944, when Germany launched its desperate Ardennes offensive, the Battle of the Bulge, The contrast in mechanized mobility had become stark. German vehicles, hoarded for months for this final push, advanced initially but quickly began to fail as their complex systems encountered the harsh winter conditions. American forces, temporarily pushed back, maintained their mechanized cohesion and quickly counterattacked once weather cleared, their half-tracks and other vehicles maintaining operational readiness, rates that German units could not match. The winter fighting revealed another often overlooked advantage of the M3's design philosophy. Its simplicity made it usable by troops with minimal mechanical training. German vehicles increasingly relied on specialized maintenance personnel, who were becoming scarce as casualties mounted. American vehicles could be maintained by the troops who used them, with basic mechanical knowledge sufficient for most field repairs. This democratization of maintenance capability meant that American units could sustain operations even when separated from dedicated support elements. A captured German panzer commander, interviewed in January 1945, expressed bitter recognition of this reality. "My tanks are technically superior to anything the Americans field, but this means nothing when they sit immobilized for lack of specialized parts or trained mechanics." The American philosophy of simple, reliable design has proven more suitable for the realities of sustained combat operations. As Allied forces pushed into Germany itself in early 1945, the M3's production reached its peak. American factories were now producing refined versions that incorporated lessons from 3 years of combat experience, improved winterization kits, enhanced suspension systems, more efficient transmissions, while maintaining the core design principles that had made the vehicle so successful. The human dimension of this industrial achievement became increasingly apparent as the war reached its final stages. Behind each M3 half-track stood the labor of American workers who had transformed their peacetime skills to wartime necessity. Auto workers from Detroit, farmland mechanics from Iowa, assembly line workers from every corner of the United States had applied their practical knowledge to create vehicles that prioritized battlefield functionality over theoretical performance. This democratization of production contrasted sharply with the German approach, which had relied on specialized engineering knowledge and skilled craftsmanship available only to a select few. The American method proved more adaptable to wartime conditions, allowing for massive expansion of production without sacrificing reliability. What German critics had dismissed as simplistic design had proven to be sophisticated in its understanding of what actually mattered under combat conditions. March 1945 brought American half-tracks to the Rhine River, the last major geographical barrier before the German heartland. As engineering units constructed pontoon bridges under fire, columns of M3s waited to cross, their passengers now veterans of a mechanized war of movement that had covered more ground in months than World War I armies had gained in years. The mobility revolution that the M3 represented had fundamentally changed how warfare was conducted, creating operational tempos that pre-war military theorists had considered impossible to sustain. A German general, captured during the Rhine crossings, offered perhaps the most insightful assessment of what the M3 represented. "We approached vehicle design as engineers seeking technical perfection. The Americans approached it as industrialists seeking practical effectiveness. History has rendered its verdict on which approach better served the realities of modern war." This verdict became increasingly clear as Allied forces pushed deeper into Germany in April 1945, while German units increasingly fought as isolated infantry, separated from their mechanized support by breakdowns and fuel shortages. American forces maintained their mechanized cohesion to the end. The M3s that had once been mockingly dismissed as trucks with tracks had helped create a mobility advantage that proved insurmountable. The human cost of failing to recognize this reality was tragically high. Thousands of German troops found themselves ordered to hold positions without mobile support, facing an enemy with seemingly limitless mechanized capabilities. The doctrinal emphasis on theoretical vehicle performance rather than practical battlefield reliability had created a mobility gap that no amount of tactical skill or individual courage could overcome. In the war's final days, as Germany collapsed into unconditional surrender, American half-tracks reached their final wartime destinations: the liberated concentration camps, the conquered Nazi government buildings, the devastated cities of a defeated Reich. The vehicles that German engineers had once laughed at now stood as physical symbols of American industrial might, having transported millions of troops across 2 continents in the largest mechanized campaign in history. The legacy of the M3 extended far beyond the European theatre. In the Pacific, modified half-tracks navigated jungle terrain that Japanese forces had considered impassable to tracked vehicles. In North Africa, they had helped defeat the vaunted Afrika Korps. Through Lend-Lease, they had provided mobility to Soviet forces pushing toward Berlin from the east. Approximately 41,000 units had been produced, a staggering achievement that represented not just vehicles, but an entire philosophy of military industrialization. After Germany's surrender in May 1945, systematic evaluation of captured German equipment revealed the full extent of the mobility disparity that had developed. German half-tracks, while technically sophisticated in many aspects, had proven consistently less reliable under actual field conditions. Their complex systems required specialized maintenance that became increasingly impossible to provide as the war turned against Germany. The American emphasis on reliability, maintainability, and mass production had created an advantage that grew rather than diminished over time. Perhaps the most profound recognition came from German industry itself in the post-war years. Companies like Mercedes-Benz and MAN, which had produced sophisticated but maintenance-intensive vehicles during the war, fundamentally reimagined their approach to military vehicle design. The emphasis shifted from theoretical performance maximums to sustainable field reliability, from complex systems requiring specialized maintenance to robust designs that could be maintained under adverse conditions. The lessons learned from the M3 program influenced not just future military vehicle design, but broader industrial philosophy. The balance between sophistication and reliability, between theoretical capability and practical functionality, became a central consideration in everything from civilian automobiles to agricultural equipment. What had begun as a simple military transport had demonstrated principles that would transform industrial design across multiple sectors. For the millions of troops who rode into battle aboard M3 half-tracks, the vehicle represented something more personal, a reliable companion that delivered them to combat and, for the fortunate, transported them home again. Veterans' accounts consistently mention the half-track, not with the technical appreciation reserved for tanks or aircraft, but with the familiar affection given to a trustworthy tool that performed its function without drama or fanfare. In this understated reliability lay perhaps its greatest achievement. The story of the M3 half-track offers enduring lessons about the nature of industrial warfare and the sometimes counterintuitive relationship between technological sophistication and battlefield effectiveness. What seems superior in peacetime engineering competitions may prove inferior under the harsh realities of combat conditions. Theoretical performance maximums mean nothing if they cannot be consistently achieved in the field. Mechanical reliability, ease of maintenance, and mass production can create advantages more decisive than marginal improvements in technical specifications. As military historians study World War II's mechanized campaigns, the humble M3 half-track increasingly stands out not for revolutionary design innovations, but for the industrial philosophy it embodied. In prioritizing practical battlefield functionality over engineering elegance, American industry created a vehicle that transformed how armies maneuvered, fought, and sustained operations. The 41,000 half-tracks produced represented not just transportation, but a fundamental rethinking of what mattered most in modern mechanized warfare. In 1941, German officers had laughed at the M3's simple design and modest specifications. By 1945, German industry was studying captured examples to understand how this unsophisticated vehicle had helped defeat what they had considered superior German equipment. The lesson proved both simple and profound. In warfare, what matters is not how a vehicle performs under ideal conditions, but how it performs under the worst conditions. By this measure, the M3 half-track stands as one of the most successful military vehicles ever produced. The ultimate tribute came not in technical assessments or production statistics, but in the transformed battlefields of World War II. The M3 half-track helped make possible operational mobility at a scale and tempo previously considered impossible, enabling campaigns that covered more ground in weeks than World War I had gained in years. It transported not just soldiers, but a new conception of mechanized warfare that would influence military operations for decades to come. For the 5 million troops it carried through the greatest conflict in human history, the M3 half-track was more than just a vehicle. It was a symbol of American industrial might, harnessed to the cause of liberation. What German engineers had dismissed as unsophisticated had proven to be exactly what was needed under the harsh realities of global warfare. The story of the M3 half-track reminds us that sometimes the most profound innovations come not from complexity, but from understanding what truly matters when theory meets reality. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.